Welcome back. Today, I'm going to be going over another AP Statistics free response question. This one is about probability distributions, including expected value and standard deviation as well. Okay, so for this one, let's start with reading the question and then we'll talk about it. So, a survey is conducted to determine the number of cups of coffee high school students drink each day. The probability distribution is given below. So it looks like the percentage of people who drink 0 cups of coffee would be 15%. 25% said they drank 1 cup of coffee per day. 30% said they drank 2 cups of coffee per day. Another 20% said 3 cups of coffee per day. And 10% say that they drank 4 cups of coffee per day. And notice that all the probabilities here do add up to 1, right? If we added up this entire row, it would add up to 1. And so what does that tell us? That tells us that this is a full set here. These are all the different possibilities. So nobody said they drank 5 or more cups, and thankfully no one said they drank a negative number of cups of coffee, because that would make a lot of sense. Okay, next let's get into the question. So the first one asks, what is the expected number of cups of coffee a student drinks each day? So I first want to discuss, well, what do we mean by the expected value? We mean that if we continue to randomly sample students again and again and again, what would be their average? Now, of course, that depends on how many students we sample, and we'd have to be doing it randomly. But that number, based on this data, is going to hone in on that average based on this data that we're given. And so the expected number is going to be equal to the sum of each number of cups of coffee that someone could drink times the probability of that occurring, right? So it's kind of like in the frequency tables. However, here we're just going straight into the probabilities. So let's start with the first one. So the first one is 0 times 0.15, because there are 15% of people who didn't drink any cups of coffee at all every day. Then there's 25% of people drank 1 cup of coffee. So we're going to add 1 times 0.25. Then we have that 30% of people drank 2 cups of coffee per day. So 2 times 0.3. Then I think you get the drill at this point. So we'll just keep going. 3 times the probability plus number of cups of coffee, 4 times its probability. And if I add all of those up, I'm getting about 1.85. And this is about what we were expecting. We always want to get something that is actually a reasonable number that we can think of as the middle of the data set or the mean. And here, noting that most of the data is here in 1, 2, or 3, getting something a little less than 2 makes perfect sense to me, right? That's about what we were expecting it to be. Okay, so let's do part B, which asks, what is the standard deviation for the number of coffee cups that are consumed? Okay, so basically, first, in order to find the standard deviation, we need to find the variance. Recall that the variance is just the standard deviation squared. So essentially, by taking the square root of the variance, we can find the standard deviation. So very simple calculation once we know the variance to finding the standard deviation. So what is the variance? The variance is where basically we need to find the sum of all the cups of coffee numbers squared times each probability, and then subtract the expected value squared. And so we're going to go ahead and do that. Now we already have the expected value, that is 1.85, because we found that in the previous part. But now we need to find the summation of all the cups of coffee squared times their respective probabilities. So let's start doing that. So that is going to be equal to, let's see, 0 squared times 0.15 plus 1 squared times 0.25 plus 2 squared times 0.3 plus 3 squared times, I think the probability for that was 0.2, plus 4 squared times probability, which was 0.1. And so there we go. and then minus the expected value squared. So all this minus 1.85 squared. So then if we do some calculations here, I'm going to get that we have, for this one, we have 4.85 if we do all those calculations, minus 1.85 squared, which 1.85 squared is about 3.4225, and that is going to give us 1.4275 as our variance. So then our standard deviation, which is what they really asked for, is the square root of the variance. And that is going to be about 1.19. And so therefore, the standard deviation is about 1.19 cups of coffee. All right, then let's move back to the question and do part C. What is the probability that a randomly selected student drinks at least 2 cups of coffee per day? So what do we mean by at least 2 cups? We mean either 2 cups or 3 cups or 4 cups, right? We mean 2 cups or more than 2. And the reality is here, the maximum is 4. So either 2, 3, or 4. And this is discrete. There are no numbers between the numbers in this case. So basically what they're asking for is the probability that a randomly selected student drinks either 2 cups, 3 cups, or 4 cups. And so I'm going to use, to do that, I'm just going to find the probability that they drink exactly 2, add probability they drink exactly 3, and add probability they drink exactly 4. So let's go ahead and do that. So for this one, probability that the number of cups is greater than or equal to 2 would be equal to the probability of it being exactly 2 plus probability of exactly 3 plus probability of exactly 4. So probability of exactly 2 is right on the chart. It's 0.3. Probability that a randomly selected student is drank exactly 3 cups is 0.2. And probability of 4 would be 0.1. So if we add those up, we get 0.6 or 60%. And so therefore, if we randomly select a student, there is a 60% chance that that student is in one of these 3 camps of drinking 2, 3, or 4, and therefore they've drank at least 2 cups of coffee per day. The other way we could do this as well is we could say, well, what's the opposite of drinking at least 2 cups of coffee per day? The opposite would be drinking just 0 or just 1 cup of coffee per day. So we could also do 1 minus 0.25 minus 0.15 as well. And if we did that, we would also get 60%. We get the same answer. So that's another way we could have done it as well, potentially. All right, well, as always, if you have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.